Welcome to Risk Engineers Talk Governance. In this episode, due diligence engineers Richard Robinson and Gaye Francis discuss due diligence in the electrical and power industry. We hope you enjoy their chat. If you do, please give us a rating and subscribe on your favourite podcast platform. If you'd like more information on R2A's work or have any feedback or topic ideas, please head to the website r2a.com.au.
Hi Richard, welcome to another podcast session.
Morning, Gaye. We're quite surprised how many people are listening to our podcasts too, aren't we?
Pleasantly surprised,
Yeah.
Absolutely. Today we're going to talk about the electricity industry and do one of our sort of industry-related podcasts. And I guess the reason for doing it is we have just been appointed onto the Energy Safe Victoria panel to assess safety arguments or safety cases from the different power utilities. And also the timeliness around the discussion around wind turbines and particularly the wind turbine fire that happened down in Portland I think it was the 30th of June this year. So that was sort of our introduction. We've got a couple of other case studies that we can talk through that we've worked on at R2A just to show you the breadth of the different types of work that we do in the electrical industry. But I guess if we start with the turbine fire, Richard, and go from there.
Well, I can't actually remember what we were going to say about it, Gaye, because I remember we were surprised at the time about it, because it did surprise us. I mean, obviously these things are foreseeable. There will be turbine fires. There's nothing remarkable about that. And the question then became how it was managed electrically. I presume the thing was instantly isolated.
Correct.
And then whether or not there was proper fire suppression systems or it was just allowed to burn out. I mean, obviously if it happened on a catastrophic day and it was dropping sparks and things around, that could be fairly complicated.
Rather than the middle of winter, my understanding was, and I think that's where the discussion is going in the investigation, is should fire protection be put on wind turbines? So they did allow it to just basically burn out. Yep. But one of the turbine blades fell off. And as you said, if that was a catastrophic day and all of the grass around it was very, very dry, then would that have started a fire? It did start a small grass fire, but the consequences weren't there at the time.
Well, this sort of flowed onto the fact that I'm still acting as an expert witness for the Cuddly Creek fire in South Australia before the Supreme Court, which is a class action. Now, I obviously can't talk too much about it, but I think what was interesting, I wasn't asked by the respective lawyers as to what I thought the decision that ought to be made. What I was asked to do was go through the process by which they came to the decision. And I think that's what all this due diligence stuff is about, which is what we hammer, precautionary due diligence. You can't always be right. That's one of the points the courts understand. But what you can do is be diligent all the time. And diligence means that you thought the thing through and you came to a reasonable basis. So it's a bit like whether or not this thing should have had fire protection systems installed. Because you can install fixed fire protection systems on remote devices, like engines on aircraft always have extinguishing systems built into them. You can buy different technologies. The Russians, for example, used to use a form of halon, which put out fires particularly well, but wasn't very good for people. So you wouldn't want to be around when the system went off, where other designs, like halon 1301, they could release it inside a computer room at the concentration that would extinguish a fire, but it wouldn't extinguish the people, which is nice and was good. But it wasn't quite as effective as the other halon stuff that the Russians were using as just extinguishing fires.
But that comes down to that balance, doesn't it? What is the risk, and then what other things does it introduce potentially?
Correct, and you'll be aware we did that other job, which perhaps I shouldn't speak about fire protection on vessels. And they had a gaseous extinguishing system which, if it got too hot, converted a number of the products of combustion to hydrogen fluoride, which basically would go through anybody's PPE, including the people trying to put the fire out, which means, in effect, if the fire got hot enough, you really had to abandon ship anyway.
Just let it go.
And so the fire control system in some ways created a greater hazard than the fire itself, which is obviously problematic and is something you should really try to avoid.
So I guess going back to the turbine fire, it's not about necessarily what was or wasn't in place. It's really the process that the operator went through to decide on what their emergency protocols were and what they did have in place. And I always say to our clients, I think sometimes it's even more important to document why you're not going to do something as to why you think it's unreasonable.
Well, I'm completely certain it would have had thermocouples all over it, so they would have known it was getting hot. And maybe all you do if you think you've got a problem like that is you just turn it to the side, feather the blades, and just turn it off and isolate it from the network, so there's no further power going into it, and it can't possibly. You'd expect at that point everything would go inert.
So before the fire actually started, it just gets hot, you think?
That's the mechanism. That's part of the question. Was what's reasonable in the circumstances? How would you know?
Yeah.
Anyway. Now, that sort of led on to a rather interesting discussion about power networks, and I don't know if anybody's aware, but there's a sort of an interesting philosophical argument going on in Engineers Australia about nuclear power and whether or not nuclear experts should be addressing the question. Now, we're kind of Gaye, because she spent all this time in Finland, and the Finns are very keen on nuclear power, obviously because they don't have much sun in winter.
No, and they didn't want to rely on gas from Russia. So
there's some very good reasons for going with nuclear power.
Correct.
And the way they go about it is particularly thorough. Now, we've talked about this previously, but they don't, until they're completely happy it's safe, they won't turn it on. They're very thorough people.
I think the last reactor that was added to the Olkiluoto system was 20 years in the making, just to get all of everything right, and they were comfortable with the safety of it.
Well, see, what's strange about this is, I was just reading a couple of things, and roughly now, last time I looked at some reports about this, Australia's about 45% renewables at the moment, but in the last year, I think twice, the renewables have actually been generating 100% of power, so the need for baseload thermal power stations has declined. Now, what's really curious about this is when you look at all this sort of stuff, is that once upon a time we used to define what we required for power by the maximum load, which was winter, which is when thermal power stations are at their best, when you've got the cold weather for the chillers and you're obviously heating and burning water to get the energy out of it. Now, thermal power stations at best are only about 30% efficient, just like cars, in terms of the energy you get out of the fuel and converting to electricity. They're quite low efficiency. And most of our thermal power stations in Australia are ageing badly. But the question is what happens with the renewables, obviously when the sun's shining in summer particularly, we get a lot of surplus power.
Yep.
And what changed though in Australia was that once upon a time peak load was winter, when we're trying to keep warm, and now it's flipped around to air conditioners trying to keep us cool. And so you've got this whole paradigm shift in the way in which you're thinking about how power is generated and how you're trying to consume it. And the entire network was never designed for that kind of distributed generation as opposed to centralised generation. And I can't, and I have to agree on all the politics of this sort of thing, that you're going to need some reliable base load, because remember, when you're trying to restart, we did the black start, red starts in New Zealand.
Yeah.
You need they're relying on hydro. You need a nice,
stable and reliable base load to be able to do that.
Base load and generator, and then you can start building the network back once you've blacked out. Now, from my point of view, we were just a bunch of engineers discussing this, trying to work out what might be a way forward. But the question of nuclear power otherwise, but having a stable nuclear generator somewhere wouldn't actually, as opposed to building coal-fired power stations, because building coal-fired power station, getting the coal out of the ground is quite a dangerous occupation. There's a horrendous lead time for a thermal power station, just like a nuclear reactor. And the Finns, if we adopt the Finnish method of making nuclear power safe, maybe that's what we ought to do, hire some Finns.
They do some cradle-to-grave stuff. They take it all the way through. But
they actually dispose of their own nuclear waste too.
They do, correct.
Unlike, we've failed that test miserably in Australia, haven't we?
The power plant, my understanding is the power plant doesn't get approved until, as I said, the cradle-to-grave and the burial of the spent fuel rods has been addressed.
So they actually competently think it through, which I don't see many other societies actually doing. So there's a whole lot of interesting issues here, and you and I we talk about these things, but we don't have a clear view on the matter.
But I think what we've seen is in the power industry, what's required or what we're using it for and how it's being generated is changing, and it's sort of that strategic approach, isn't it, to an industry that you almost got to look that 20 to 30 to 40 years out. What does it look like, and then what do we need to achieve that? Whereas we keep creeping up on it, and there's no headroom left in the network.
Yep, N-1's pretty much gone, so far as we can tell.
Everything's ageing, so we're sort of at a stage where things are starting to come crashing down, but we don't have an overall policy or framework to say this is what the best solution is, or the optimum solution for either Australia or different parts of Australia to say, and that's what we're all going to work towards. It's unfortunately very political. And political timeframes, which, you know, when you're talking about those sort of projects that are 5 and 10 years out, certainly don't fit the political cycle.
Well, you've heard my little story about my solar system on my roof, which, you know, when I put it on, it was a pretty good return for the power I put into the grid, you know, but just as it paid itself off, the inverter died and I had to replace that. Now they give us such little amount of money, the whole thing wasn't worth the trouble, let me put it that way.
No, you only get the benefit from what you use. You know,
well, no, they don't do that anymore. They,
okay.
They consume, they charge you for what you use and you get a little bit back for what you sell.
Oh, that's really not a good deal, is
It's
it?
not a good deal anymore.
So it's really that precautionary approach. What do we want to achieve? And I guess we've talked about it before, I think, on one of our podcasts, but Richard and I were the expert risk management experts on the Powerline Bushfire Safety Task Force, and then I followed on the committee when
this
they were
is a rise from the Royal Commission into the Black Saturday fires where killed 173 Victorians.
And they took that precautionary approach and put in refugals, which...
Ground fault neutralisers for those who don't believe in refugals.
Thank you, my technical brain. So they put those in, and our understanding is that they've worked really well and haven't had, where they've been installed, haven't started a bushfire in those particular areas.
In the last, what would it be, 6 or 7 years now?
6 or 7 years, yeah.
Although there were other problems.
Yes, there was some hardening of network, and that comes back to that, you know, what do you want your network to be? And it hasn't ever been designed to do those things. So you almost got to put a line in the sand. What do we want it to achieve? What will our current network get us to? And then what do we have to do to achieve the rest?
Yep.
So that sort of brings us to the end of a very diverse discussion around the
certainly was.
Electricity industry. Not a one-size-fits-all solution for any of this, I don't think, but if you take the philosophy that Richard and I have always had, that it's safety in design and designing for optimum outcomes. What are your options that are on the table? What do you want to achieve first? What are your options on the table, and in the circumstances, which are the best?
And the political fights we're having aren't helping.
No.
There would be an optimum that would work for Australia, and for some reason we seem to be politically unable to actually think it through.
I think it has to be divided into two things, though. It's what's the best technical solution for Australia, and then how do you get it through the politics of it? I mean, we've said this many times. As a young engineer, you'd always told me it doesn't matter how technically right you are, you have to be on the political ball as well.
Yep.
So thank you for joining us, and we hope you listen next time. Have a great day.